Okay, so we're going to electrochemistry again, and starting with the whole concept of oxidation.
Is this starting?
Oh yeah. Okay.
And reduction. So electrochemistry is based on these two processes, oxidation and reduction. One of the things we want to start off with is memorizing what these two things are. And there's an old saying about a lion. So here's my lion. By the body. Here's claws and tail. And his name is Leo.
What?
And he's Leo the lion. Okay? He's not happy with his current incarnation.
Yeah.
But he helps us remember that loss of electrons is oxidation.
Oh my god.
So whenever we see a species losing electrons, that species has been oxidized. Okay? Loss of electrons is oxidation. So before, we saw that solid gold can become gold ion and liberate 3 electrons. So we say the gold has been oxidized because it lost the electrons. Okay? But there's more to Leo's name. Leo's a lion, and so often, when angry, he says, grrr. And that reminds us that grrr, gain of electrons is reduction. So, loss of electrons is oxidation, gain of electrons is reduction. Leo the lion says grr. And I can help you remember what we're dealing with when we do electrochemical reactions. Okay? Now that we have this little mnemonic in mind, we can find the oxidation half reaction and the reduction half reaction that go into electrochemical reactions. So let's take a look at sodium metal, so sodium solid, reacting with chlorine gas. And we see that this is a vigorous forward reaction, given that there's enough energy present. And the result of this is sodium chloride. So we're going to balance this and we'll say we'll make 2 units of sodium chloride out of having 2 units of sodium react with 1 unit of chlorine gas. So we believe that this is a redox reaction, and we're about to demonstrate that by remembering what Leo told us. So this is a redox reaction. So a redox reaction. And the word redox comes from reduction and oxidation. So we call it a redox reaction because it contains both a reduction and an oxidation. So let's look at these species, and when we look at these species, if we can identify which one has lost electrons and which one has gained electrons, we'll be able to identify this as a redox reaction, and we'll be able to see the 2 half reactions that come together to make the redox reaction. So we're going to introduce a concept that helps us identify what's going on with the atoms even before the reaction occurs. And this concept is oxidation number. And what the oxidation number is, it's the charge. And oxidation numbers are only ever done for atoms. They're not done for the whole species. So when we look at any species, we're going to break it down and find the oxidation numbers, because the oxidation numbers are the charge on the individual atom. And if we track the oxidation numbers, we can tell an oxidation from a reduction, just by tracking it. And that's the charge on the individual atom. But we call it an oxidation number because sometimes it's hidden inside the molecule. So let's look here. we've got two sodium metal atoms. What's the charge on them? Okay, what's the charge?
0.
0. There's no charge written here, so we know it's 0. So this is starting out with an oxidation number of 0. Let's go here and let's look at this sodium chloride molecule and see if we can figure out the oxidation number of the sodium. There's no charge in this overall molecule, so we know the total charge is 0, but that doesn't mean there aren't charges present. What charge is present on the sodium? Positive 1. We know that because it's an ionic compound. Sodium is always the positive partner in an ionic compound, always. And so we have a change from 0 to 1 in the oxidation number of the sodium. Did this number increase or decrease?
Increase.
It increased. So it must be a, is it a reduction or an oxidation? It's an oxidation. If it was a reduction, the number would have gone down. So this is an oxidation. Does it make sense that this is a loss of an electron?
Yes.
Yes, you went from a place where the electrons and protons were equal, so no charge, to a place where it had one extra positive charge. So it's lost an electron. So now it has more protons than electrons, or a positive charge. And that's an oxidation. An increase in the oxidation number is an oxidation. So it makes sense if we talk about oxidation means the oxidation number is going up. That's another reason for using that rather than just using the word charge. All right, let's take a look at the chlorine. What's the charge to start with the chlorine?
0.
It's 0. All right. Later on, we see the chlorine after the reaction has a charge of?
-1.
-1. So chlorine has gone from 0 to -1. What has happened to its oxidation number?
Reduced.
It's been reduced. It's gone down. So this is a
Reduction.
reduction.